I'm going to do three things. I'm just going to define a problem. In fact, there are three of them facing enterprise and distributed video conferencing today. Put forward a solution and throw it out and ask for some help. The nature of the problems we've been solving in terms of real-time secure data in motion related to multiple parties and issues of some sensitivity we've been dealing with for a very long time in courts of law and police stations. But that notion of real-time, immediate, and it's all pervasive. So what we've seen happen is that video conferencing is no longer the domain of the closed network, and that's got really fundamental considerations for some of the challenges we're trying to embrace these days. Three main issues I wanted to define, and one of them is a little bit awkward. Firstly, cost. Traditional video conferencing was always a very big expense. So latency and resilience. We're seeing information being pushed over the public networks and the net and the internet, and so resilience. Lots of catchy words being used in the last few years in terms of self-healing systems and error resilience and what have you. But fundamentally, from our perspective, it was really simple. Is that in a court of law, if there was reasonable doubt about evidence being given by a child or a police officer from an unknown location, and that may lead to a case being turned around, it was unacceptable. So we needed to go out and find technology that would solve those issues to do with packet loss and high latency transmissions. Last point was scaling and redundant transmission. Probably that's best discussed in the context of an example that I'll give you. So the issue is certainly more bandwidth is going to make a tremendous difference. It already is, but it's the efficient utilisation of the bandwidth combined with more bandwidth that we believe is what's required. So we're removing the heavy lifting components from the middle, and we're pushing them out to the end. And so we were able to solve the problem for the Royal Flying Doctor Services using a series of very inexpensive high-capacity video routers. And that model immediately, because we're talking about multiple paths, provides redundancy, some self-healing capabilities that we've talked about forever. And as a consequence, the Royal Flying Doctor Services probably spent $1.6 million on fuel that they would have otherwise had to spend on rusting technology. I think that's a practical outcome that means a lot to regional Australians. And the way that sort of model is working in the future is that the deployment of infrastructure across public and private networks that is federated by nature and can be shared to support multiple applications. So we're seeing councils deploy this infrastructure, make it available for emergency services, make it available for telehealth, rather than every agency needing to buy and invest in redundant, duplicated technology. And the response we're getting is that 85 to 95% of the communications is actually occurring within the local area network. It's people on the same floor plate, because there are only 2 meeting rooms in the building, involved in a conference with other people who are present on the floor plate. That trend we're seeing across the board is being driven by the iPads, being driven by everything else. So I suppose the tale here is this is the second part of the problem. Is this redundant transmission to the core and back again? It just makes no sense having 250 high-definition video signals leaving the firewall only to turn around and come back again. And the way that we do this is using conventional video routing technology, deploying the apparatus locally, taking all of that traffic off the network. And it's only the location-to-location streams that are being managed across the links. That has a huge impact on the performance of the network. So just to wrap up in terms of our experience and where we think this technology is headed, is that there are 3 big opportunities that we're focusing on. And one is obviously provisioning this technology as a service, because of its ability to be virtualized, such that every point of intersect we could essentially have a virtualized video router infrastructure, such that all of the video traffic that may be occurring in Southeast Australia is staying in Southeast Australia, and break that all the way down to the building of origin if need be. So we're moving away from the centralised to the decentralised, and already we've got great examples of completely distributed infrastructure where every one of you becomes a point of transmission and processing So distributed infrastructure, and we generally believe there's merit in looking at this sort of architecture with a way of supercharging the NBN. I suppose the last, and bring your own device, of course. I think one of our predictions is we're going to see the end of codecs in the next couple of years. There'll be no dedicated devices rendering up video images. It'll all be software-based. So from our side is that we're busily working to put this sort of infrastructure in place, working with our customers to try and bring down the cost, and using the example of the Flying Doctors as a model, and looking for opportunities and partners and ways of accelerating the rollout of this technology. Because it's removing a huge amount of pressure on infrastructure that's being deployed, and it's tackling some really awkward questions in terms of the connectivity between those who are on the NBN and those who may not get it for some amount of time. Thank you very much.